Greetings, friends. Welcome back to this week of probability and stochastics video homework series. Today we will be going for number 2 of homework 2. And so here we have noisy channels here. Given the probability of x of 1 equals 0 is equal to 0.2. Probability of x of 1 equals 1 is equal to 0.8, and for all of 1 is less than or equal to k, less than or equal to n. And you have all these other features here. So let's get down to it. So for the first one, we have find the probability of x of 2 equals 1. So we're gonna do it in a matrix way here. So let's see. We'll go p x of 2 equals 0. P x of 2 equals 1. That equates +1 plus 1. So, and we make a matrix. This pretty much aligns with these guys here, alright? And we know here will align with this. So let's make another little equality. 0.2, 0.8 times 0.6, 0.4, 0.3, 0.7. And you do your little matrix multiplication. Bust out your TI-84 calculator, if you will. Just kidding. You arrive at 0.36 and 0.64. And the answer we are looking for, this guy here, is right here, and it's also right here. So our answer of probability of x of 2 equals 1 is 0.64. Quite simple. Moving on, we have find p of x of 3 equals 1. So for this one, we're gonna do this here. P of x3 equals 0. P of x of 3 equals 1. And there it is. So we're gonna kind of like skip the formalities of writing this out here, but basically it is p of x of 2 equals 0, p of x of 2 equals 1. That's like we're kind of writing it right here. So we got our answer from the last one. So it's 0.36, 0.64, and what are we multiplying that with? The classic 4 horsemen here. 0.6, 0.4, 0.3, 0.7. And you will bust out your matrix multiplication again. You get 0.408, 0.592. And what we're looking for is this guy here. So p x of 3 equals 1, 0.592. Cool. So for C, we have find this guy here. Alright, so could be a bit more complicated. So we kind of want to break this down, right? So this will more or less become this. X1, 0. and this is all divided by alright. Let's see. So we want to try to find this whole thingamajig here, and how we could achieve that is by getting our usual 2x2 matrix of this guy here, as this works for pretty much many things in this problem. We have a 0.6, 0.4, 0.3, 0.7, and we square it, and that gives us 0.48, 0.52, 0.39, and 0.61. And what we're looking for in this one is the probability of x of 3 equals 1 and x of 1 is 0, and that will be, I believe, this one right here. But if you would like me to write it out, this is essentially what it looks like. This is 0 and x1 is 0. So this is like 0, 0 right here. This would be 0, 1. This would be 1, 0, and this would be 1, 1. And we're just looking for this guy here. So we're kind of just like plugging in at the moment. P x of 3 equals 1. We got that here. P x of 1 equals 0. They already gave it to us, I believe, 0.2. So we just multiply it. So we have 0.52, 0.2 over 0.592, and we'll bust out your TI-84, 0.176, and that's your answer right here. Say for D here, we have a limit n approach to infinity, probability of x of n equals 0. Okay. Alright. So we write this guy out. Px of infinity equals 0. P x of infinity equals 1. That quite equates to limit of n as approach infinity. We have 0.2, 0.8. And we have our classic matrix here. And it's squared by n. And so for this one, if you throw like as n approaches to infinity into here, applying it, you would get 0.2, 0.8 times 3747, 47 here, and 37 here. And if you would multiply that out, that would give you 37 and 47. And what were we looking for? X of n equals 0. And say this was infinity, n would become infinity. So this guy here. Our answer is 3/7. Thank you for watching.